Welcome to BTEC Revision. Today's lesson is on exponential graphs. By the end, you should be able to interpret exponential growth and decay graphs and plot exponential graphs. How would you plot y equals e to the power of x on a graph? We can start by plotting some values for x. Let's pick -2, -1. It's important to have a range of negative values and positive values. You can also choose 0, +1, and +2. And we can use the equation y equals e to the power of x, plug in the values for x to work out the value for y. Y is equal to e to the power of x. We can replace the x value inside of this equation to work out the y value. For example, for the first value of x, -2, we can replace e to the power of -2, which is equal to 0.14. Similarly, we can do this for the other. Or x is equal to -2, our y value is going to be equal to 0.14. For x is equal to -1, we have a y value of 0.37. And for x is 0, we will have y is equal to 1. For the next value, we have 2.7. And for the next, that's 7.4. Now we have a set of values, we can plot our graph. So let's start off with x is -2, and that's y is equal to 0.14. So that's about there, roughly. And for x is -1, our y value is 0.37, about 0.4. So that's there. And for x is 0, we have y is 1. And for x is 1, we have y is 2.7. And for x is 2, y is equal to 7.4. So that's all the way over there. If you carried on the line. For these questions, you will need some graph paper. If you don't have any, you can find online versions of graph paper and you can print them. Once you've got your graph paper, pause the video and attempt these questions. We have already plotted our y equals e to the power of x graph. So I've got that drawn for us on this graph. Next, we can look at the second value. We can take x to be -1, -2, 0, +1, and +2. So plugging these values into our calculator, into the equation, you can work out the y value. We have already plot y equals e to the power of x. So we can move on to the second. Y equals 2 to the power of x. And we can work out the values for y by plotting the x values of -2, -1, 0, +1, +2 into the equation to work out the values for y. So plugging in x is -2 is going to give us 1 over 2 squared, so that's 1/4. The next value is going to be 1/2. And for power of 0, that's always going to be the value 1. And 2 to the power of 1 is just 2. And 2 to the power of 2 is 4. Okay, so let's plot these values now. At -2, that's going to be a y value of 1/4. So it's about there. And for x is -1, that's 1/2. So that's about there. For x is 0, the y value is 1. And for x is 1, our y value is 2. And for x is 2, our y value is going to be 4. So you can see this value is not far off from the previous value of y equals e to the power of x. because e is a number close to 2, it's 2.7. So you should see a pattern similar. Drawing the line of best fit, we can see this is roughly what the graph will look like. Looking at the next function, y equals 3 to the power of x, we can do similar calculation and work out for our x values -2, -1, 0, 1, and 2. So our y value here is going to be 1 over 3 squared, so that's 1/9, and 1 over 3, so that's going to be 1. 3 to the power of 1 is 3, and 3 squared is 9. Plotting these values, our x is -2, so that's going to be 1/9, so it's very small, about there. And for the next value, x is -1, that's going to be 1/3, so it's about there. And for the next value, it's over there. X is 1, y is going to be 3. It's going to be slightly higher than the y is e to the power of x. And for x is 2, so it's going to be 9. So it's going to shoot way off the scale there. Okay, plotting the line of best fit, we can draw a nice curve going up like so. So I'll just fill these in using the calculator. Now we can plot these. So x is -2, and the y value is going to be 7.4. So it's off the scale. It's roughly there. And for x is -1, going to be a y value of 2.7. It's about there. And x is 0, y is 1. And x is 1, y is 0.4. And for x is 2, y is 0.1. And drawing the line of best fit give us a curve. Well, hopefully we can see a pattern here. If we take a exponential function with a positive power, we can see the curve is going to go upwards, starting from the left, going upwards towards the right. And if it's a negative power, as for the blue line, then we're going to start off high and the exponential is going to decrease. So we can say that for the positive value, we have an exponential increase, and for the negative value, we have an exponential decrease. This can also be known as exponential growth and exponential decay, respectively. Now pause the video here and attempt this exam question on graph paper. We'll start with labeling the axes. On the y-axis, we will have current, measured in amps, and on the x-axis, we'll have time, which is usually measured in seconds. And we will solve this using the same technique by drawing the table. We will have our time value. We can set starting with 0 because you cannot have any negative time values. So we will have 0, 1, 2, and then we'll plot 1 in the middle, 5, and the last available value on the graph, 10. And the current, I, we can work out. We'll start with the first value, 10, take away e to the power of -0, which is 10 take away 1, so that's 9. For the second value, it's 10 take away e power of -1, and that's going to be equal to 9.6. So I just filled in the rest of the values using my calculator. Now we are ready to plot the graph. So for time is 0, we will have a current of 9. And for the second, and that's the end of the lesson. If you would like to boost your grades, why don't you visit us at btecrevision.com and try some exam questions and quiz questions. See you next time.